this is part 2 of lesson 7.3 and 4, and we're going to use SOH to find side lengths. If you remember, there are 3 trig ratios, and those trig ratios are sine theta equals opposite over hypotenuse, that's the SO part, SOH. The CAH part is cos equals adjacent over hypotenuse. And the TOA, I should say tan, is tan theta equals opposite over adjacent. So we get our SO, CA, TOA. And this symbol, theta, I've said it a couple times now, but not actually explained it. Theta just means angle. So some unknown angle. The sine, cosine, and tangent ratios are used to find the measurement of side lengths and angles in right-angled triangles. When you encounter a problem where you have the length of one side and at least one of the angles that's not the right angle, so one of the acute angles, it's possible to use SOH trigonometry to find the length of the other side. You can't use the right angle triangle to label your triangle, but if you have a different angle, you can. So we're going to work through 3 examples where I'm going to show you how to find a side, and then there's a practice example for each solving method. There's 2 different solve methods. We're going to work through both. It boils down to basically just 3 steps. Label your triangle with H, O, and A. Decide whether it's sine, cos, or tan, and then set up your equation and solve it. So we're going to work through an example. Find length AB to the nearest tenth. Well, AB would be the side between A and B. Or we could call that side C, but the question says AB, so we're going to call this AB. We want to find this side. So, step 1, label the sides relative to the angle. The angle we have here is 37, so we're going to label it from 37. So we go across the triangle to label the opposite. Across from the 90 is the hypotenuse. And the last side, the one between the angle and the 90, is the adjacent side. This is where putting the boxes around H, O, and A become important because there is actually a side A. It would be this side, but we'd label it with a lower A, so just be careful when you're labeling. All right, that's step 1. Step 2, let's figure out whether we're using SO, CA, or TOA. How do you tell? Well, you highlight the side that you know. We know this side is 11 centimeters. H. You highlight the side you want to find. We want to find AB, which is O, and now you go look at SO, CA, TOA, and you decide which one you have the 2 sides for. Well, I'm going to write it SO, CA, TOA. So we can use sine if we've highlighted O and H, which we have. We've highlighted O and H, so we're going to use sine. Notice none of these other ratios would work. A and H, we're not trying to find side A, so there's no sense to use cosine. TOA, we are looking for O, so that's okay, but we don't know side A, so we can't use tan. The only ratio we can use is sine. So what do we do now? We write sine theta equals opposite over hypotenuse. Sine theta equals, I'm going to write O over H, opposite over hypotenuse. And now we're into step 3, solve the equation. How do you solve it? You substitute what you know. What do we know? We know the angle is 37, so we can write sine 37 equals the opposite side is the side we're looking for, AB, and the hypotenuse is 11. So now we're just solving this equation. Well, how do you solve this equation? Well, sine 37 is just a number. So we have a number equals AB divided by another number. If you want to solve, you want to get AB by itself. How do we do that? Well, we do that with opposite operations. What's the opposite of divide by 11? It's multiply by 11. So to get rid of the divide by 11, we'd multiply both sides by 11. The 11s would divide away. We'd just have AB. And that's 11 times sine 37. To find our answer, we just type that in our calculator. 11 sine 37. 6.6199. Let's call that 6.6. And we're working in centimeters, so we have centimeters. 6.6 centimeters is our answer. All right, so we just solved for our first side using trigonometry. Now I said there's two different ways to solve, and it boils down to where your unknown is. If the side you're trying to solve for ends up being on top, the way we solve is we multiply by whatever number's on the bottom. There is a scenario where what we're looking for is on the bottom, and there's a different solve step for that, and I'll show you that in a couple examples. Now, when you're using your calculator, I should have mentioned this at the beginning of the video, your calculator needs to be in degree mode. And you can tell your calculator's in degree mode if, now let's see, I don't know if you can see that or not. I have a D right there. That button says D. You need your calculator to be in D mode or degree mode. So your calculator might say D, it might say DEG. You need to be in degree mode. If you're not in degree mode, you kind of have to play with the mode or the settings button to switch between modes. It could be in R or rad or G or grad. If it's in any of those modes, you need to change it. Sometimes the easiest way to change it is just to reset your calculator. If you can turn your calculator off, it'll reset it. If there's a button in the back that's reset, you can hit that button in the back. For this calculator, I think I have to hit mode. Nope, I have to hit second mode, and then I get DEG, rad, or grad. I want DEG, so I hit 3, and that puts me in degree mode. You need to be in degree mode because your angles are in degrees. If you're not in degree mode, you won't be able to use your calculator to solve these questions. You'll get the wrong answer. All right, let's try another example. Find the length of TS to the nearest tenth, round to 1 decimal place. Well, TS would be the side between T and S, which is this side. And we're going to label the triangle from 22. Well, from 22, we'd have opposite down here, hypotenuse across from the 90, and TS would be our adjacent side. So what do we know this time? Well, we know 9.2, that's the hypotenuse. We want to find TS, which is A, so now we look at SOH. TOA. We're going to know one of those. We have A and H. So is with O and H, so that's not sine. Cosine is with A and H, which is exactly what we have, A and H. So we're going to use cosine. So we write our cosine equation. Cos theta equals A over H, adjacent divided by hypotenuse. Plug in what we know. We know our angle is 22. We know A is the side we're looking for, TS, and we know H is 9.2. Notice we have the side we're trying to solve for on top again. So to solve this, we just need to multiply both sides by 9.2. And we get 9.2 cos 22. It's really important to do the 9.2 multiplying first because some calculators might mess this up and do 22 times 9.2 and then do cosine, which would give you the wrong answer. You want to write that number on the bottom that you're multiplying by in front of cosine or sine or tan. So here we go, 9.2 cos 22. And we get 8.53, which we're going to call 8.5. And we're in centimeters, so we have 8.5 centimeters. All right, and we have another practice question here that you can try on your own. It should work out to a similar solve as the example, so you can try it right next to it. And then check your work, make sure you're following the right steps, and see if you can come up with the answer. Let's try our last example, example 3. Find the length of DE to the nearest tenth. All right, what side's DE? Well, we've got E and D right here, so our DE is here. If we label the triangle from 9 degrees, we have O, H across from the 90, and A is DE. If we check our SOH, we have O is 9, and we want to find A. So, does not have O and A. CAH does not have O and A. TOA does have O and A, OA. So we're going to use tan this time. Tan theta equals O over A. And what you might notice is all of these solving steps are kind of looking the same. And it's because sine, cos, and tan equations are all the same equation. They're all built the same way. It's either sine, cos, or tan of an angle equals a fraction. They're all set up the same way, so the solving's very similar. The only difference is what button you're pressing on your calculator, sine, cos, or tan. Where the solving steps can get a little different is in this example, and let's take a look for a second. 9 degrees, we're going to plug in 9 degrees for our angle. Opposite side is 9. The adjacent side is DE, the side we're looking for. This time, the angle we're looking for is on the bottom. This isn't always going to happen when you use tan. It could happen when you use sine or cos. It just depends on what sides you know. We don't know A. A is on the bottom, so the thing we don't know is on the bottom. To solve for it, we actually have to multiply both sides by DE and then divide both sides by tan 9, and that looks complicated. So instead, what we're doing is we're basically just switching these two terms. And we get 9 over tan 9 equals DE. Now, why does that work? Well, that works because if we did it like this example, we'd multiply both sides by what's on the bottom, DE. That would bring the DE in front of tan 9. And to get DE by itself, we would divide away the tan 9, which puts it on the bottom. So it just depends where your unknown is. If it's on the top, we solve it by multiplying. If it's on the bottom, we solve it by dividing. So let's solve one by dividing. 9 divided by tan 9 is 56.8. And we're still in centimeters, so DE is 56.8 centimeters. Now that number seems like a really big number. And when we're looking at a number like 9 centimeters, that seems like, okay, well maybe this is wrong. Well, it's not wrong, because if you think about the angles, it kind of makes sense. 9 degrees is a really small angle. So by proportion, we should have a really small side compared to this angle would have to be 81 degrees, which is much bigger. So this side should be much bigger. And that's kind of how it works. How did I know this is supposed to be 81? Well, when you have a triangle, remember all three sides in the triangle, all three angles in a triangle should add to 180. So if you know two angles, you can subtract them from 180 to find the last angle. Okay, that's it for solving for sides. Try some practice questions, practice 1 and practice 2. Check your answers on the course website. And be sure to watch part 3 where we solve for angles. Thanks for watching, and I'll see you next time.